This is a quick video on the logical operators. We've looked at the truth table, and it's sometimes challenging for us to sort of see that the truth table is an attempt to provide all of the combinatorial possibilities for two truth values given n number of propositions or declarative sentences. That's a bit abstract, so let's try and pin it down a little bit. So let's take a set of possible ways that things could be. So here we have a set of 6 worlds. So if we look at these 6 worlds, then we can say things that are true or false about each of the 6 worlds. So we're going to take the example of emeralds are green. So let's say there are these 6 worlds, and by world here we mean completely distinct universe. So you could think of them as sort of parallel ways things could be, alternative scenarios, let's say, and that are unrelated to one another. So in these set of 6 ways things could be, it's true sometimes that emeralds are green, and it's false sometimes that emeralds are green. So if we look at our space of possible ways things could be, we see that in some of them it's false that emeralds are green, over here in these guys, and over here it's true that emeralds are green. So remember, when we set out our truth table, we'll have something like P, and then if it's just the one variable, the one sentence variable, we'll say it's either true or it's false. And let's say we don't know what P is. P is some declarative sentence. Then we know that a declarative sentence is either true or false. So we know that emeralds are green is either true or false. And we say that the set of possible ways things could be splits in 2 along those lines. So let's keep going. Now, as soon as we introduce the logical operator and, the terms change a little bit. So remember, we've got P and Q, and we know we've got our conventional arrangement of truth values. T, T, F, F, T, F, T, F. And we know that it's true only when both conjuncts are true. Okay? So this thing as a whole is true only when both conjuncts are true. So TFFF. Okay, so if we have a compound sentence joined with an and, or held together by an and, emeralds are green, being P, and salt is yellow, being Q, then we're going to look at our set of possible ways things could be and determine in which of them is it the case that emeralds are green and salt is yellow. And once we inspect them, we see that, well, it's only here that that's the case, right? So it's true here and it's false here. Now, why is it true here? It's true because P is true and Q is true in this case, in world 1. The others correspond to other circumstances. So, for example, it's true that emeralds are green. Let's give this another color here. Whoops. Whoops. I lost that. Too bad. Okay, I'm going to continue anyway. So as we saw, we've got P and Q, T, F, F, F. It's true only in this case. This is the case where P is true and Q is true. That corresponds to world 1. How about the next one where salt is, let's say P is emeralds are green is true, but it's not true that salt is yellow. Well, world 2, world 5, and world 6. These correspond to the situation where emeralds are green and salt is not yellow. So you can see here the salt is blue in that case. But emeralds are green. So it's true that emeralds are green, and it's false that salt is yellow. But since we're dealing with a compound sentence, we know that the claim that emeralds are green and salt is yellow will be false in that case. So let's look at the next one. This would be the case where emeralds are not green and salt is yellow. So that looks like this case right here. Okay. And why is that? Well, because salt is yellow is true, but emeralds in this world are not green. Let's look at the last case, false, false. And guess what? I don't have a false, false, but let's build a false, false over here. And here we've got red salt and red emeralds. So in world number 7, it's false that emeralds are green, and it's false that salt is yellow. So that would correspond to the fourth case. Okay. So I hope that's helpful. Let's keep going. How about or? Let's talk about the disjunction. So or is true. In all but the fourth case, or is true. So what's the fourth case? The fourth case is the case where emeralds are green or emeralds are not green or salt is not yellow. It's not the case that P and it's not the case that Q. Do we have anything like that in the fourth case? Well, no, because what have we got here? We've got emeralds are green here, 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 and here. We've got salt is yellow here, here, here. So it looks like our worlds are falling into case 1, 2, 3, but not 4. So let's take a look. So this would be an example of 1. This would be an example of 2. This would be an example of 2. This would be an example of 2. This would be an example of 3. And this would be an example of 3. We don't have any 4s. We could draw a 4 over here if we wanted to. Again, the world where salt is red and emeralds are red. Okay, so that would be world 4. Okay, so you can see that the truth table is an attempt to represent all of the possible combinations of truth values for these compound sentences. So how about the if-then? So if emeralds are green, then salt is yellow. So how does this look again? It's TF, TT. So what do we know? We know that it's false only in the second case, where P is true and Q is false. Do we have any cases like that? If emeralds are green, then salt is yellow. We've got lots of cases like that. Here, emeralds are green, but salt isn't yellow. So that would be the second case. How about emeralds are green and salt is yellow? We've got that. That's the first case. And again, here we have the third case. Okay, so if this were the way things are, then we'd know that this is false as a whole because this is one of the false cases, the case where emeralds are green and salt is not yellow. Let's continue. How about emeralds are not green and salt is yellow? How about it's not the case that emeralds are green and salt is yellow? So where is it not the case that emeralds are green and salt is yellow? Okay, So it turns out that in all these cases, except for world 1, this is true. So let's do, it's not the case that emeralds are green and salt is yellow. We know that's TFFF. False only in the first, or true only in the first case, but now we're going to negate that. So we've got FTTT. So how did I get that? Again, just to remind you, set up my conventional set of truth values. Evaluated the inside part first. The parentheses tell me what the order of operation is. So first I evaluate for AND, get TFFF, then I take all of that, that gets negated, FTTT. So that's the truth value for not the case that P and Q. Now let's take a look. So what have we got? We've got one scenario where it is the case that P and Q and all the others satisfy 2, 3, or 4. Okay. Emeralds are green or salt is not yellow. You can pause the video and study that one if you want. And then that's it. Okay. So I hope that that helps you sort of see the connection between the truth tables and the set of possible ways things could be.